Hey guys, welcome. This week we're going to be talking about water, so A1.1, very first topic for some. And I think this mind map really nicely summarizes things. These pictures have mainly been taken from BioNinja, a fantastic resource. If you haven't checked it out, helped me out loads when I was new to the syllabus. Like their pictures are amazing. And when we think about water, we're mainly focusing on the fact that there's hydrogen bonding. So this hydrogen bonding is caused by an imbalance in electronegativity. So up in the top left, we can see this picture here that if there was a no electronegativity, then the molecule itself would look like this. But because oxygen's nucleus has 8 protons in it, it has a greater pull on the electrons of those of hydrogen. So hydrogen's obviously only got 1 proton, 1 electron, and it's those electrons that will mainly find associated with the oxygen. That means we have like an unequal distribution of electrons, and the oxygen is slightly more negative than the hydrogens, which are then, because there's the proton left behind, they're slightly positive. So, like this asymmetry gives us what we call a polar molecule, where we have a difference in charge. So, it has the 2 positive terminals and a negative. And then there's going to be a weak bond between them. So between a positive hydrogen and the negative oxygen, we then have this like weak interaction when they become close to each other. And we can observe this with a few special properties. So, for instance, adhesion, which is sticking to something, and cohesion, sticking to each other. Now, a nice way to be able to see this would be like in the meniscus. When you look at water, for instance, let's just jump out of here and got a little picture down here. So here's a meniscus. This is where the water is adhering to the side, and the cohesion is more observable with things like pond skaters, that are able to, like a fly sitting on the water, like the little ones that dance around a pond, or also just like placing a leaf on the water. This is showing like you've got that the cohesion between the molecules, which gives us that surface tension. Now, here's a closer look at those pictures there, showing us that slightly positive terminals. Sorry, I was just moving the little picture, little camera, and the slightly negative terminal here of oxygen. And that means we're going to find these weak intermolecular force that we call hydrogen bonds. Now, this gives it a few properties: cohesion, adhesion, we mentioned, and also the solvent properties. So water is a major component of our blood. It's able to break things down like sodium chloride into the different components because this is an ionic compound. And chlorine is negative and it's attracted to the positive hydrogens of water, and like something that is not an ionic compound will not dissolve in water. Ionic compounds readily dissolve, and non-polar substance will not mix with water, so it's like hydrophobic. For instance, up here is when we pour oil on top. It is non-polar, hydrophobic, and will repel. Now, here is my web sheet that I made, and what I'll draw your attention to. If you flick through, you can. I really love the little interactive elements of like a web sheet versus a worksheet or even a presentation. Like it's much cleaner to like really view. Here I've got like some little hydrogen bonds going on, indicated in the blue. I would say that this is a little bit not 100% how I'd want this to be showing, but when we turn up the temperature, you can see like the main thing is that they're moving around randomly like you would have a gas molecule or something. When molecules are just attracted to each other by what we call London dispersion forces. But what's cool here is that you can see every now and again you get this little flash of blue, and that's what hydrogen bonding is. When they're close to each other, it just adds a greater attraction between the molecules. Like methane is got a similar relative atomic mass, so it's a similar size molecule, but yet it's a gas at room temperature. And why is water a liquid? It's because of this additional interaction of hydrogen bonding. Now I've turned up the temperature quite a lot there. If I turn it down a bit, like the thermal energy, you can see there's a lot more hydrogen bonds going on. Now, what's interesting, what doesn't show in here is like lattice formation. I don't think I actually have a slide on it. I have to have a look. But like a lattice, like when an ice forms, for instance. So why do we get ice forming, and why is it less dense than water? Let's see if I can pull up a slide quickly. And it's the idea that the hydrogen becomes more regular, hydrogen bonds become more regular and more uniform. Here we go. I've got a nice picture here. And then what that does is it means that they will form a less dense substance. So they're more spread out because of this regularity in the hydrogen bonding holding much better. And then it acts as an insulator, so it will form a thermal barrier, and that creates a bit of a warm cushion of water just underneath the ice that allow fish to survive. So what's nice in this web sheet is one of the ways that you're going to be tested, because of course hydrogen bonding and the properties of water is quite basic, but like they've added two little bits into the syllabus around two animals. One is the ring seal, and if we click through we can see it's different adaptations. It's thick blubber because water's got a really high specific heat capacity and a high thermal conductivity. So that means it holds heat really well, and it's able to remove it from another substance really well and take a lot of energy from it. So, if you've ever been swimming when the water's slightly cooler, like 20 degrees even, and which sounds relatively warm, but after a while you're going to start feeling really cold because it's able to take a lot of the heat out of you. And blubber helps them stay insulated and stay warm. And also in a black-throated loon, they've got a packed plumage, so lots of air being trapped, like wearing a jumper. Another way that they are able to make the most of the properties of water is through, like, they've got the cohesion of the water molecules gives viscosity. So having large web feet allow them to produce like propulsion. Same, of course, for a ring seal. It's got fins. It's able to use that viscosity of water to propel itself. A loon is also a bird that hunts underwater, look for fish. So it's actually got denser bones than what you would expect to help it control its buoyancy. And it's able to create a streamlined shape just like a seal. But a seal is naturally streamlined, whereas a loon will form itself into like a torpedo shape. And then the fat also helps it regulate its buoyancy. So as always, at the end, I've got a nice little mind map to help put everything into context for you. And of course, a few interactive activities to test yourself. So feel free to go and check out this web sheet in the comment section. I've put a link. And then of course, how do you memorize these key words like cohesion, adhesion? They're very similar. Sometimes you can get them jumbled. So check out cramly.study for my flashcards, my free flashcard system, which use spaced repetition. I guarantee if you embrace this, and like there's like a little Tamagotchi to help emotionally manipulate you there as well. I'll just jump to the web page quickly. You can see you get a little Tamagotchi, and once your cards are done for the day, like your 10 cards, you're able to interact with it, and it will evolve. So this is mine. I just use it for testing. So of course I have not got a very evolved Tamagotchi pet here, and feel free to name it yourself. But yeah, underneath topics, you've got A1.1 Water and all of these cards. So go check this out. It's a really nice way to consistently build your knowledge over time, because there's a lot of scientific evidence to show that repetition is key to take information from your short term to your long term memory in order to get it through that hippocampus so you can remember it. Okay, so cramly.study, and don't forget to check out this web sheet to test yourself before any test you have in class. Feel free to drop a comment if there's anything you want to request. I'm going to slowly work my way through the curriculum, and of course, share, like, and subscribe. Ciao.